Here we have a alarm program for a Arduino, which includes an RFID, motion sensing detection. The RFID is used to turn the alarm system on and off. It is in a permanent on position for the purpose of this program. At the beginning we have the libraries that are included into the program to make the alarm function work. We also have the definition of where our pins are located for our LEDs and motion sensing abilities. We also have here the setup for a melody system. That way, if I wished, if the individual wished, they could change and program a specific melody for the alarm to execute. This includes the time duration of what the melody will take overall. So if the notes are played out in sequence, the last note will last the duration of the actual melody. So in other words, it would be like note A4, D4, A5, D5, so on and so forth. Executes, plays this little melody on note D5 at the very end here. It will stay at a D5 for the rest of the duration of the actual melody. Here we have the RFID address, establishment for the memory addressing. That way we can sit there and have external variables. That is including here for the X and Y axis. We also start up our actual devices with the MFRC 522. In the void setup, we have establishment of the actual variables for X and Y axis. The also establish the X status, whether or not the alarm is going to be on or off. Here we have the addressing and wire assignments for the MPU 6050. We also have the establishment of what we're going to do with our LEDs and the serial establishment for the actual RFID readers. Down below we have the actual X status. Here, this is a little note that we use to troubleshoot whether the status is on or off. This is the alarm set function, and this is the actual alarm function. So the alarm set function is used to establish an initial X and Y axis variable for when the actual system is turned on. The alarm function then runs and reads this and thus resets after a certain amount of time. So long as the alarm function doesn't move more than 1,000 or continuously move more than 1,000, then the alarm will not trigger. If it does, then obviously the alarm will set off. This is our if function for checking whether or not a card is present and what the card serial number is. We will match that down here by taking the first 10 bytes of information. It translates it into a hex code. Here we have the actual hex code that are of accepted RFIDs. We have 2 assigned at this point. Down below we also have the X status set functions. When it is authorized, when this variable is true, then it will read whether or not the X status is 0 or 1, which means on or off. as denoted here. When it does this, we will go to the F status, function status, and thus trigger our LEDs. Thus, if the LED is on, it will show green for 3 seconds and then turn off. If the alarm is off, it will show red for 3 seconds and turn off. The alarm set function basically will start the motion detection. This sets up all the motion detection necessary. It will also read the initial values of X and Y. Once it reads the values of X and Y, it has a delay of a little bit, and then it will go on to the next function. The next function, as stated up above in our loop, is the alarm function. The actual alarm function restarts the actual reading of where the placement of the gyroscope is, gives you it already has a value set by the above XY values. It gives us a difference if it is more than 1,000 to the previous one, then it will actually set off our alarm. Our alarm located down below. In this case, we have actually manually set our tones. In this case, we could also delete this whole area here and put that melody that we have already set up in. But in this case, we wanted to try to go for a tone value that was similar to when the police or the emergency services would go by. As this is a very annoying value, it is a well-known value, and it is used to shock the individual that is trying to steal the equipment and make him put it back down. This also has a delay set for how long. This is the actual tone value and what pin it goes on. The delay after this is actually put at 2 seconds, which will allow the whole system to restart every 2 seconds. So you have an extreme delay, unfortunately. This you can change as you need. You can put it at 20, you can put it at 10. The only delays you do not want to change is that of the tone values or those of the actual melody values. So if I wanted my melody here to go on for a duration of 1,000 milliseconds, I would have to fill this area out with the appropriate tones up until 1,000 milliseconds has been, or 1 second has gone by. And then I could put initiate melody down here with a value of a pin 8. It would go tone. Instead of tone, it would be melody 8. Correction, the tone that would play would be on pin 8. It would be melody, and then the duration. This wraps up our program for the Arduino. It is relatively simple. There is a lot of excess that we can actually trim down. However, at this time, it was good. It was used to develop our prototype, and obviously customization will come at further dates. Thank you very much.